students. This is question 3, problem set number 2 for matrix algebra. Question 3 is, let A equal the matrix A sub 1, 1, A sub 1, 2, A sub 2, 1, A sub 2, 2. Show that if D A sub 1, 1 times A sub 2, 2 minus A sub 2, 1 times A sub 1, 2 not equal to 0, then the inverse of A equals 1 over D times A sub 2, 2 negative A sub 1, 2 negative A sub 2, 1 and A sub 1, 1. And going through this problem and seeing how I should approach it, the closest thing that you could do to solve this problem is look at the identity matrices for a solution. And I would go about that, thinking about these identity matrices. A simple example for A over here. If we had a matrix A, 2, 3, 4, and 5 times an identity matrix of A, which is 1, 0, 0, 1, that would still equal the same matrix as before. So we can see this little formula over here, I times A equals A. And it's a multiplicative identity. So you use that all the time, like 1 times 100 is still 100. Same kind of thought process. And just like as a recap, I kind of have this section of identity matrices. And basically it's just, as I said before, I can make this smaller. It's a multiplicative identity, such as A times 1 equals A, or for the matrix, it's A times I equals A. And approaching our problem for question number 3, basically, you have to look at the identity, but the inverse of the identity. So my solution, you start with the multiplicative inverse, which is basically the inverse of A times A, which comes out to D1 over D times A sub 2, 2 negative A sub 1, 2 negative A sub 2, 1 and A sub 1, 1 times A sub 1, 1, A sub 1, 2, A sub 2, 1, A sub 2, 2. And if you multiply this out and you fill in for D here, let's not go through that step right now. Let's go with multiplying these two matrices together. That will lead to some things canceling out. So we have the negative A sub 1, 2 and A sub 1, 1 times the A sub 1, 1, A sub 1, 2. Those cancel out, and you get left with zeros after you multiply them together. And then the A sub 2, 2 negative A sub 1, 2 times A sub 2, 1 and A sub 2, 2. You'd basically have that listed in the new matrix as A sub 1, 1 times a sub 2, 2, minus a sub 1, 2, times a sub 1, 2. I think I missed, yeah, this is a sub 2, 1 times a sub 1, 2. And then you also put that here, because it's basically what I got when I multiplied these together. And then the next step is you want to multiply it by 1 over d. And this basically kind of, I wouldn't say cancels out, but it makes it into a simplified identity, which can be written as the identity matrix of 1, 0, 0, 1. And what this basically, well, this is significant because this means that the inverse of A would equal the inverse of A. And that's basically an identity matrix when you multiply it out. And that's how I came to this conclusion, and I hope you found this interesting. Thank you if you finished this all the way to the end. I really appreciate it. And I hope you guys all have a good one, and good luck in matrix algebra.